Hello, everyone. Thank you and welcome to our monthly research talk. Today, I'm going to present our speaker, Fangyu Gai. He's a first-year Ph.D. student at School of Engineering, University of British Columbia, Okanagan Campus. He's supervised by Professor Chen Feng, who is the co-cluster lead of Blockchain at UBC. And Fangyu Gai research interests lie in distributed systems, cybersecurity, as well as blockchain technologies. He is currently focusing on off-chain scaling technologies, including payment channels, networks, and side chains. Fangyu, welcome and thank you. You can have the word now. Thank you.
Okay, thanks, Danny. Can everyone hear me? Yeah. Hello, everyone. Hope you all had a great Easter. And I'm Fangyu Gai. And thanks Vicky for inviting me for this talk, and thanks Danny for setting up. And it's an honor for me to be here to talk about my research, the off-chain scaling solutions, and a little bit more about myself. I received bachelor degree in software engineering, master degree in computer science, both from China. And right now I've been pursuing my PhD degree since last year. And currently I'm focusing on off-chain scaling solutions and alternative consensus algorithms. So for today's talk, I will go through 3 questions here. Why does the blockchain need scaling? Second is, what is off-chain scaling? And then, how do off-chain protocols work? So let's get started with the first question. Why does the blockchain need scaling? Well, before answering that question, let me make some concept here to make sure we're stand on the same page. Okay, so what is scaling, scalable, and scalability? So as I assume many of you may have been reading some articles, and these words may confuse you. So for an informal definition, in a scalable system, as we move from small to large, things should not get incrementally worse. So let's think about Google as an example. At the beginning of the Google, they may only have hundreds of users, so several servers were sufficient to provide the services. But right now, the number of users have been growing exponentially, but we can still have the same nice and smooth user experience. And that's because Google keeps adding more and more computers, more and more servers, and developing more and more sophisticated technologies to make it scalable. So what do we expect for a blockchain to be scalable? Well, A scalable blockchain is one that continues to meet the needs of increasing users and transactions. But right now, current blockchains like Bitcoin and Ethereum, they are not scalable. And I'll show you some facts. The first one, look at this picture. It's the cryptocurrencies transaction speeds compared to Visa and PayPal. Look at these numbers. The mainstream payment system Visa, the throughput can go up to 24,000 transactions per second, but the current cryptocurrencies like Bitcoin and Ethereum, they can only process transactions less than 100 transactions per second. So it's not sufficient for large-scale adoption, right? And I'll show you another fact. I assume many of you have heard of CryptoKitties, which is one of the most popular apps in Ethereum. And the goal of the game is to buy a virtual cat, and then you can breed them and trade them. Each of them has its unique identity and a unique DNA, which recorded in the Ethereum. And you can trade them via Ethereum transactions. And after it launches in late 2017, it became so popular that it almost disrupted the Ethereum network. And look at this picture. Basically, we can see that the CryptoKitty trades transactions account for about 15% of the network, and
Hello? Hello, Fangyu? Fangyu, can you hear me? Fangyu?
lost. Sorry.
Oh, sorry.
Hello. Is it on?
Yes, now we can hear you. Thank you.
Yeah. Can I continue with this page?
Yes, start this slide again, please.
Okay. Oh, sorry.
Yes.
Yeah, this slide. Okay.
Yeah.
Okay, let's continue. So the CryptoKitty became so popular that it almost disrupted the network, and we can see the CryptoKitty trades transaction account for almost 15% of the volume, and and a lot of transactions got pending. From these two facts, we can answer the question, why does the blockchain need scaling? It's because the current blockchains like Bitcoin and Ethereum are not scalable. It's very far from web scale adoption. Then here comes the following question, why are the current blockchains not scalable? So I will not going to into details about this, but all you need to know is that it depends on the nature of decentralization, because every single transactions need to be stored and executed by every single nodes in the network, which means the performance of the whole network is no better than a single node. Then this issue brings us to talk about the scalability trilemma. So basically, the scalability trilemma is says that we can any blockchain-based system can only have 2 out of 3 properties: decentralization, security, and scalability. The notion of decentralization is that every node in the network is equal and there's no central authorities in it. And by scalability, we mean that it continues to meet the needs of growing users and transactions. And security is a guarantee that our assets are always safe. Since security is always our priority, so we can only choose decentralization or scalability. For example, Bitcoin choose decentralization other than scalability, and the Visa sacrifice decentralization for scalability, right? So at this point, you may want to ask, can we break this scalability trilemma? And I think the answer is yes, and there are a lot of researchers going on to solve this issue. Basically, there are 3 directions. The first is alternative blockchain consensus architectures. So instead of using POW as consensus, we can use new consensus algorithms to scale the blockchain. And there are a lot of projects like Algorand and Cardano. They're using POS as consensus, and Tendermint is a consensus machine used by Cosmos. They use practical Byzantine fault tolerance algorithm, and IOTA use a directed acyclic graph as their consensus. And another direction is on-chain solutions. Here we mean on-chain or layer 1 solution. We mean that we will change the protocol to achieve sort of scaling. For example, the Casper, this project is under development in Ethereum community for Ethereum 3.0, and the core technique is called sharding. So basically, sharding is to divide users and transactions into different shards, so that the transactions can be kept in this shard and don't have to be broadcast to other shards. In order to achieve scaling, they simply adding more and more shards into the system. And another example is parallel chain. So this protocol is to produce blocks, produce multiple blocks at the same time instead of only one in a POW. And compared to this solution, here comes the off-chain solutions, which is referred to layer 2. So intuitively, we build off-chain solutions based on layer 1, which is the underlying blockchain. So we don't have to make any changes to the underlying blockchain. Instead, we build our own off-chain protocols on top of it. So there are a lot of projects going on, like Lightning Network in Bitcoin and Raiden Network in Ethereum. They are both a payment channels solution, and Plasma is proposed by Vitalik and Joseph in Latin Network to create a secure sidechain. And due to time limit, today's talk will only focus on the off-chain solutions. So the next question, what is off-chain scaling? Well, currently there is no strict and clear definition of what is off-chain scaling, and I'll try to explain it in several sentences here. So let's look at the first sentence. Off-chain protocols use public blockchains as the settler layer, so aka the main chain. So like I mentioned before, this protocol is built on top of the main blockchain. And the second sentence here, every parties have some deposits frozen on the main chain. Right, in order to spend some money off-chain, you have to deposit some money in advance into the main chain, right? It's like in a coffee shop, like in Starbucks. If we want to use the gift card, we have to deposit some money into it so we can buy coffees using a gift card, right? And the third sentence, parties can do unlimited transactions off-chain and only touch the main chain when it's necessary. So the off-chain scaling should allow parties to do unlimited transactions and only make on-chain transactions when it's necessary, because the whole goal is to reduce the on-chain transactions. And here comes the fourth sentence. The main chain has no idea what happens off-chain, but it can tell who is right or wrong when conflicts happen, and the result is trusted. So it's the main idea of the first sentence, because we use the underlying blockchain as a settler layer. So we only talk to them when conflicts happen, and we can trust the result it's determined. And the last sentence, when someone wants to withdraw or exit, he or she needs to provide the proof of possession. It's because the miners on the main chain, they don't know about the off-chain. They don't know the current status of the off-chain protocol. So if someone wants to exit or withdraw some money from the sidechain, they have to prove they actually owns that money, right? So am I making any sense? And if I'm not, I'll show you an example from high level. So here, I'm gonna introduce a new concept, the smart contract. I assume many of you have heard of it. And all you need to know is that it's just a bunch of code deployed on the main chain, and it can bridges the gap between the main chain and the protocol. So so the sidechain is set up by deploying the smart contract, and after that, Alice and Bob, their users, can make some deposit into the smart contract, and from then on, they can use that money to make off-chain transactions, and it's unlimited, and you can make arbitrary transactions off-chain. And then if they want to close, they want to exit or withdraw some money, they just send a request to the smart contract by providing some proof of possessions. And here the proof of possessions, we mean that it should include some signatures from the participants. And if Bob is malicious, let's say he had some transactions, and at this point, Alice can challenge him by submitting a challenge message to the smart contract. And at this point, the smart contract can be the judge to determine who is cheating or honest. So let's think about this off-chain solution, and it sort of give us a three-layer architecture here from bottom to top. the main chain, off-chain protocols, and application layers. The main chain can provide trustless services to the upper layer, and the second layer protocol, the off-chain protocol, can be implemented depending on the user case, and at the same time it should expose an API to the upper layer so that public nodes can verify the integrity inside the network. And as for the application layer, you can develop applications in need of scalable, fast, and reliable blockchain infrastructures. And in this layer, you can even use traditional database techniques. You can store data and process data in your own server. So let's see what benefits can off-chain solutions give us. Let's get started by privacy here. In Bitcoin or Ethereum, all your transactions are public online. Everyone can see it. There's no privacy at all. But if you move the transactions off-chain, you don't have to broadcast them to others. So your transactions are private. You can keep your privacy. And then interoperability. Current cryptocurrencies, they don't talk to each other. You can make cross-chain transactions to each other, but using off-chain techniques, you can do that. You can create some protocol to make some cross-chain transactions. And backward compatibility. Cryptocurrencies, they won't change much because any major changes can cause a hard fork. It's unaffordable by the committee. So there's no backward compatibility at all. But if we use off-chain solutions, we can create our own protocols, and we can keep updating our protocol to provide backward compatibility, right? And I don't have to mention the scalability and low fees because all the transactions are executed off-chain. And the last but not least, instant transactions. It's very crucial in payment system because you don't want to wait for an hour to get to know that your pizza order is finalized, right? And so we have learned what is off-chain solutions. Then how do off-chain solutions work? And to answer this question, I'll take payment channels and sessions, for example. Let's get started with payment channels. In order to here we have Alice and Bob as our users, and a multi-sig contract deployed on the blockchain. And multi-sig contract means the money inside the contract can only be spent with the signatures from both Alice and Bob. So they cannot, both of them cannot deny any transactions in the payment channel. And in order to open a channel, Alice simply deposits 5 coins into the channel, and a timeout is set. If the timeout passes and no one retrieves that money, Alice can get her 5 coins back. And then after the channel setup, Alice and Bob can make unlimited transactions. Say here, Alice sent 1 coin to Bob, and the balance of Alice is 4, and Bob's balance is 1. And then transactions keep going, and the balance of Alice is 3, and Bob's balance is 2. And you can make more transactions here. And then if they are being business are done in this channel, they want to close the channel. At this time, they simply upload the latest transactions to the multi-sig contract, and then the contract will decide how to divide the money, right? And they will the contract will send 3 coins to Alice and 2 coins to Bob, right? This procedure is very straightforward. And then if we add another user, Carol, we can use multiple channels to form payment channel networks. In this example, the Alice and Carol don't have a direct channel between them, but they don't have to build a new channel because they can use existing channels with Bob. And at this time, Alice wants to send 1 Bitcoin to Carol, so he just told Bob that please help me forward my money to Carol. And then Bob, if Bob agrees to that, he will do that. And note that the 2 steps should happen atomically. I won't go into details about how to realize this atomically. So, but we just keep it in mind, right? We can do that. Use the smart contract. And another thing we should note is that in order to stimulate Bob to participate in this payment, an extra fee should be included so that this fee can act as an incentive for Bob to participate in this payment, and everyone is happy. And that's the example of payment channels. And here is another example called SetChain. So SetChain is basically a new blockchain, but they are attached to the mention using smart contract. And compared with payment channels, every users in the SetChain can make transactions with each other. They don't have to build up additional channels. And another good thing about SetChain is that you can create your own SetChain depending on your own use cases. For example, you can build a social network, decentralized exchange, retailers, and online games and macro payments. You can build various different kinds of SetChains, and they all attach to the mention. And here, attached means that we rely on the mention for security. And I'll give you an overview of how the SetChain work. And in this example, we have several elements. For example, the mention, the MC means mention, is our underlying blockchain. And there's a smart contract deployed on the mention. And then we have validators. It's just a fixed group of servers which do the consensus. And it doesn't matter what the consensus is. It's just they can make agreements within this group. And we have a bunch of participants here. And to start this session, participants keep sending transactions to the validators, and the validators will achieve agreement by proposing a block here, and they not only propose the block, they not only store the block in locally, they also commit the hash of the block to the mention, and this block, this hash, represents all the transactions inside the block, and it stays as a checkpoint in the mention. So basically, the sidechain is to compress thousands of transactions into only one on-chain transaction on the main chain. So that's how they scale the blockchain. Okay, that's it for sidechain. And let's summarize today's talk by proposing some open challenges for future work. Although the off-chain solutions seem very promising, they're still in early age, and they still face many challenges to overcome. And the first one is online watchdog requirements. This means, in payment channel or sidechain, it requires users to watch their assets to prevent some malicious behaviors happen. Because if they stay offline, their assets may be stealed, their assets are no longer safe at all. And then long withdrawal or exit time. Here, I mentioned before that we can get instant transactions by using off-chain solutions, but we cannot get instant withdrawal or exit because every withdrawal or exit will cause an on-chain transaction. So we have to wait the on-chain transaction confirmed, then we can be sure that we can withdraw that money. And then here, withholding attack. So the previous slides, we can see that the validators commit the blockchain to the main chain only a hash. The checkpoint only is a hash. The main chain actually have no idea about what's inside the block. So what if the malicious validators commit the block without publishing its content? So if it refuses to publish the content, everyone will not know what's inside the block, and they cannot provide the proof of possession to the smart contract. So they cannot withdraw or exit from the sidechain, right? And here is the withholding attack. And then locked and fragmented collateral. Here we mean that we have to deposit some money to enter the payment channel or sidechain. So within the timeouts, we cannot use our money at all. So it will reduce the fluidity. And then the last one is it always exists, because if you introduce new protocols, you introduce new attack plan, because there always are bugs and flaws in the protocol, so that other malicious may exploit them to steal your money. So it's less safer. And that's it. Thanks for listening, and I'm ready for answering questions. Thanks.
Thank you, Fangyu. Any questions?
Thank you.
Can you hear?
Sorry, it's not clear.
Oh, we don't have one. Sorry. Can you just write it? Yeah.
So can you hear me better?
Yeah, it's good.
So in the last few years, a lot of people have been implementing different blockchains, like you mentioned, on-chain scaling solutions. But the problem with on-chain scaling solutions, as you mentioned, is that you kind of lose a lot of privacy. You leave all of this trace for everyone to observe. So do you think it's a good or worthwhile effort for people to pursue on-chain scaling solutions, or is it potentially hard to keep on-chain scaling solutions limited?
Sorry, I didn't hear the last sentence. Can you repeat that?
My question is, would it be a mistake to let's pretend like some proof of stake algorithm allows, 100,000 transactions per second, right?
Yeah.
But it was on chain, and so there was a permanent privacy issue because we could never get rid of that data. In your view, would that be a net worthwhile pursuit, or would it be better to figure out off-chain solutions and minimize on-chain solutions?
Okay, so your question is it better to continue use on-chain transactions or to use off-chain solutions, right?
Yes, that's it.
Yeah, actually, the new blockchain they are proposed are using different consensus algorithm like BFT or POS, and we cannot guarantee the security of it because currently the Bitcoin and Ethereum are still the most secure blockchains in the world, and because they are using POW. Right, so it's hard to attack it, but there's still some new blockchains coming up and claim they can achieve hundreds of transactions per second because they are using some new techniques like BFT. But in order to achieve that high throughput, they have to sacrifice some decentralization, because the transactions will not be broadcast to everyone, to each node of the network, right? So they have these assumptions to guarantee that it's not the protocol itself, and off-chain solutions is just another directions, right? You can use it for theoretically thousands of times of scaling to use the off-chain scaling. So back to your question, I think it's just different directions. You can choose a new blockchains or off-chain solutions. They're just different directions to scale the current blockchain. Yeah. Am I making any sense?
Any other question? No? Okay.
Hi, hello. I just have a question around the payment channel and you use. Maybe if you can go to the slide with Bob and Alice transferring money to each other.
Here or
the network? Yeah, just this one. Yeah. So it wasn't really intuitive to me how sort of the smart contract decides that someone is not like trying to cheat. So so say Alice withholds and transaction, says, hey, actually I didn't transfer that one Bitcoin to Bob. Like how is that resolved?
Oh yeah, I can answer that. It needs more details because each transactions is signed both by Alice and Bob, so each one of them keeps their local view. They all know how much money they spend, right? And as for the smart contract, they should upload the latest one. But if at some point I give you some money and I ignore this transaction, I just use an older transaction to prove to the smart contract, and at this time you can challenge me by providing the latest one, right? And how do we make the order? We can simply use account number to tag each one of the transactions. Like the first transaction is 1 and the second transaction is 2. And if I use the first transaction to exit, and you can use the second one to challenge me. And if you succeed, I will get punished. Okay, is it clear?
Yes, thank you.
Yeah.
Yeah, thank you.
Any other question? No?
I have another question if nobody else.
Good. I'm sorry.
Hi again. So my second question is regarding the validators in the site who validate the hash of the block to the main chain.
You mean the section?
Yeah. This
Section?
one. Yeah. So
Yeah.
V1, V2, V3, V4. Typically, who are the validators? This is obviously a degree of centralization, right?
Yeah.
How do you prevent sort of malicious validators? Again, if you're going in this direction, why do we even need validators at all? Database.
Yeah. It's a good question, and we need some sophisticated technology to prevent that. In this cluster, you can assume it's only one operator. It's only one operator who manages all the section, the whole section. And if the operator can be malicious, he can manipulate transactions and he can commit any data he wants, right? But at this point, the participants can see, can validate the block content to the checkpoint, see if they are matched. If they are matched, they can, which means the operator is honest, right? If it doesn't match, we can use this block as the proof of possession and submit the block to the smart contract and let it judge, because the smart contract know the checkpoint, but he don't know the content of the block. If we can give him the block, he can judge who is cheating. So this is what I mean by the withholding attack. If the operator withhold the block, so the participants don't have the proof to prove that they actually owns that money. At this point, their assets are not safe at all. But at this time, they can exit from another technique, and due to the time limit, I cannot explain in detail. But I can refer you to read the project called Plasma here. I can show you Plasma. It's proposed by Vitalik and Joseph, and it's well designed, and there are many companies to implement Plasma, and there are a lot of mechanisms of how to exit securely proposed. So you can read their research. Okay.
Yeah, sure.
One last question from me. I think currently Peter Risen, who is a researcher out of Vancouver, is presenting the best arguments against Lightning, the Lightning Network as a viable solution. I'm wondering what your thoughts are about on-chain fees being a problem for off-chain solutions like the Lightning Network.
I'm sorry, I don't understand the question. You mean the on-chain fees versus the off-chain fees?
Yeah, it's currently one of the best arguments made by Peter Risen is that on-chain fees creep into off-chain solutions because channels require some amount of money to be in the fees. So I'm just curious what your thoughts are on on-chain problems creeping into this off-chain solution.
Oh, okay, I got you. So your question is the Lightning Network requires additional on-chain fees to set up a channel, right?
Yes.
Yes, and I think it's a problem of the payment channels, but it's already reduced the burden from the merchant, right? Because you only need two on-chain transactions to use the Lightning Network to open the channel and close the channel. But once the channel is set up, you can do unlimited transactions. So on average, you have decreased the transactions fee compared to the on-chain transactions. So it's still better than on-chain, I think. But there are still some new proposals to reduce the on-chain fees by to open the channel. For example, I remember some projects they build up some hubs like a big node in the Lightning, and they can handle some transaction fees, and so that your participant will be cheaper. Yeah.
One last question. We have time for one more. No? Okay, thank you, Fangyu, and have a great
Yeah, thank you. Yeah, thank you everyone for listening.